Okay, good afternoon, everyone. I'm Chris Ramsey with Clever Culture Systems. It is now 4 p.m. Eastern Time and 1 p.m. West Coast, where I am. So I hope your day is going well. I am going to run through. This is the third webinar series, and some of you have been with me before. I can see some good friends that I've spoken to already. So welcome back. And today, hopefully, I'll give you some new update on the APAS independence and some of the new directions that we're taking and new products that we're going to be rolling out soon. So welcome, and this is going to be very quick. About 10 minutes of presentation and followed by 10 minutes of doing a workflow review with the instrument behind me. So I'll be demoing it behind me, and that way you can ask questions. And there's a Q&A box that you can ask any questions. And at the end, we'll have a question and answer center session that I will go through. So thanks for being here. And it should be about 20 minutes, 22 minutes, the entire webinar. What I'm going to do is switch over to our presentation. I'm going to share that with you, and then we'll get started. Here we go. Okay, so I always start by stating the problem or the challenges that we see in the laboratory, that you're facing in the laboratory, and laboratory medicine. Since I've been involved in this IVD and this business, is that I hear about three things that are very important. Top three things are accuracy of results, turnaround time, and consistency. And here at Clever Culture System, for the past 10 years, really our vision is to leverage the technology of artificial intelligence, which is our core strength, to deliver diagnostic tools to staff your laboratory to full efficiency. And what I mean by that is, when I was in the lab, it didn't really inspire me to move tubes around, do things that was non-sort of value added. It really inspired me when I found something that helped. So this is our hope, that we can help you deliver faster results to your doctors. So the questions we often ask ourselves are, how much time do microbiologists spend on the bench reading plates each day? And how much of that is negative plates? We find out between 50 to 60% of the plates that are urines are negative, and above 90% for MRSA, VRE, CRE. So that's a lot of plates that are just negative, that a very talented, skillful microbiologist has to spend going through every day. And are you being asked by your administration to cut costs, to be more efficient, to focus more on bringing tests that are more revenue generating? Is staffing a challenge in your region area? So those are sort of what we ask moving forward, to understand the pain points. And you can ask yourselves any of these questions as we roll out this session. So we all understand the problem facing clinical labs at the moment. There are a lot of manual activities within the microbiology. Microbiology, I still look at it as quantitative, but a lot of qualitative, right? We have to look at plates, we got to visualize it, we have to smell it. There's still a lot of things that in the past were very difficult to fit into an automation or a software that was algorithm driven. And now we're at a precipice of having artificial intelligence moving us through some of these difficulties in the past. And APAS independence certainly is that one step towards making better automation solutions for microbiology. Here, the APAS independence is the first FDA-cleared intelligent imaging and machine learning technology to read and interpret the presence of significant bacterial growth. Unlike other automation systems that are already available, total lab automations, APAS is a standalone. It's small and it doesn't take up too much time, and its implementation is very, very easy. So it's much easier to get this and start with this, even if you're thinking about long-term automation, total lab automation. This really helps create more capacity for the lab. So the main things about the APAS is that it's FDA cleared, it's available now, it is very easy to integrate, and I'll show you some of the data on that. It has stellar performance across many different countries. So it's definitely the AI is working better than we expected, and it's affordable. How it works is that we take culture plates and we put it on the APAS. And what it does is that it takes a very high resolution image, and that image gets reconstructed into a digital form. So every pixel is really counted. And based on 10 years of teaching the algorithm, training the algorithm, let's say for urines, we were able to get it to a point where it behaves just like a microbiologist. It can interpret the results. It can really look at all these morphologies of E. coli, Klebsiella, or whatever you throw at it, that we threw at it. Just like you and I, it just does it 3 times faster. It is more accurate and delivers remarkable consistency. It eliminates variability between microbiologists from day shift, night shift, weekend shift, and it avoids some of that unnecessary reworks. Bottom line, it will save you time and give you more capacity to your lab and give you faster results to your doctors. Just a quick view before we actually demonstrate the system. It has 3 main parts to it. It has the inlet module. Here is where we load all of our culture samples. Then it has the imaging center. This is where really everything happens. It takes a very high resolution image, which is stored, and it could be stored on your LIS as well. And that could be used for future reference, as well as if you're a teaching or academic institution, then it can use it for training. And once it takes that image, then the AI takes over and interprets the results and enumerates the colonies. And based on your SOP, it puts all the negatives, non-significant growth, in the outlet portion, and all the positives are stacked up neatly in these single stack that could be accessed at any point. So the point is that you can move 240, 200 samples an hour through here, and all your plates are read, interpreted, all the negatives are auto-verified automatically to your LIS, and only the positives are going to be handed to the microbiologist for further identification and AST. And here's the top view where you can load up to 240 samples an hour. And then an image every 16 to 18 seconds, a plate is processed through and the results are sent out, and the positives and reviews are already sieved out for the microbiologist. So that's all they have to do. So imagine if the microbiologist comes in at 7 a.m., it starts working, takes the plates out of the incubators, and then usually they sort them into the kind of piles that they like, and then they go through them and read them, and negatives go into LIS, they write notes, and carry on. And then when they're done with all that batch, then they go through setting up for MALDI or ID through molecular and AST. Now imagine all of that is going to happen in a fraction in an hour, and by 7 a.m. they already have all of these ready for them on their desk to just be ID and do susceptibility. So you can imagine the results going much faster to the doctors. Perhaps even therapy changes can happen that same day if we can get the ID and AST out. So this is where accuracy come into play too. And I've seen enough workflow studies that, we're looking at a plate and we have to sort of assess, is this less than 10 to the 3, less than 10 to the 4, and 10 to the 5? And everybody has a different method. I've seen some crazy ones to just enumerate. And what the microbiologist sees is this, right? That's what we see. And then here's what the APAS sees. Even the ones that are very hard to see, these colonies that are jammed up against the corner. And what's important is that it makes that assessment it turns it into a very accurate count. So if you really want to look at anything above 10 colonies, then it really just sorts everything above 10 colonies very accurately. So there's no gray area when we're doing accounting. So you get very accurate counts, consistent counts, day in and day out. And the report looks like this. You're going to get a designation here that gives you the plate type and interpretation of the results. You get a description, a detailed growth description of the organism formation. You get a lot of detail there, and also enumeration. And then you also have some manipulation tools if you want to change the image and play with it and so forth for training and other purposes. So that's in a nutshell what it really does. It's very simple. Now let's look at some of the performance. Here's an early study that was done and on urine for blood agar and McConkey. And what's remarkable, again, when you train the algorithm properly long enough with all the organisms that you can get your hands on across 3 continents, then you get this 99 plus specificity and sensitivity. Usually, in any sort of a diagnostic, as you've seen, if you're going to really push the sensitivity, you're going into the weeds, you're going into noise level, your specificity suffers, and vice versa. If you really care about specificity, well, you have to sort of sacrifice sensitivity. Here, we don't have to do anything. And when we looked at everything that was put through the APAS, it can recognize all of these different organisms just as well as a skilled microbiologist. So this is what it's really remarkable, this stellar performance day in and day out. And in a real life setting, this was a poster by Glenn Hansen's lab published in 2019, and not published, I'm sorry, presented at ASM 2019. And he did urine studies, 720 urines, and he found very similar performance, 100% sensitivity for negative identification, 100% sensitivity for true positives. But for a lab operation, what's really important for him is that 50% or so reduction in manual reviews. So now he has that time given back to his microbiologist to do other things, especially during this COVID area. He found it very useful to have the APAS independence. And on besides urines, MRSA, surveillance, Karen Carroll's lab in Johns Hopkins did a study and presented it last year, 2020 ASM, and she's publishing it soon, the study. And she found, again, stellar results, that 100% positive percent analysis and 98% negative percent analysis. And interestingly enough, 3% of the discrepancies that were presumptive positives were actually called correctly by APAS that were initially missed. And these were positive. So again, speaks to the accuracy and performance of the APAS independence. And the workflow is pretty simple. What the APAS really does is that once you load, you take all your cultures and load the APAS, it just removes all the negatives out of the workflow. And it hands you what's actionable, the actionable results that you have to do IDAC. So it's really a we call it an auto verification engine for urines and surveillance cultures. Here's an example. I want to give you an example of those that haven't seen this. I do workflow studies across the country. This one is actually near me in San Diego. And they have a front-end WASP automation system here. And this is what it looks like, their daily reads for urines. And when you implement the APAS, that all changes quite a bit. All of that 9 steps or 9 areas pretty much go away because the APAS takes over. And what is interesting, or I should say important, is that same thing what Glenn Hansen saw, is that these guys also see 50% decrease in workload. So here's 4 hours out of a day that microbiologist is gaining to do other things and attend to parts of the lab. So again, very, very compelling. Now, I'm going to give you some new stuff since some of you guys have seen those before. So what's coming up? We are obviously so far working on MRSA. MRSA is in the hands of FDA. Any day we're going to hear from them. So that'll be FDA cleared, but that module is available. MSSA is available. VRE is available. And what we're also working on in the pipeline is CRE, ESBLs, Group B streps, and what I'm really excited about is the AST disc diffusion. So let me show you where we are with that. So for those of you that have kept up with UCAST and CLSI this year, some of the guidance on disc diffusion, they're trying to crunch the number. Now the recommendation from UCAST last year was that you can read 6-hour cultures instead of 18 hours. And what I want to show you is that we're able to actually see 6-hour cultures with the APAS. And what's great about the APAS is that it can recognize and read all the discs as well. So basically, you drop your discs, you run your incubator for about 6 hours, and within that, after that 6 hours, we're able to read. So shrinking the 18-hour normal incubation time to 6 hours, and automatically setting zones of inhibition, reading the disc, and reporting all this information quite accurately to your LIS. So for those that are already doing some disc diffusion or thinking about moving towards disc diffusion for certain things, then here's another possibility that the APAS can do and really automate that, and takes a lot of work off the microbiologist's hands and provides a lot of accuracy. So in conclusion, what the APAS allows us to do is focus on clinically actionable data. So it removes all the negatives, it auto verifies them right away. That allows the doctors to make decisions right away. 7 a.m., all the negatives are removed, that is reported. So if there's anyone in isolation or observation, they get to release that patient. Same thing with the positive, we can get to them much faster and release those IDs much faster. And avoid massive automation cost. If you don't have the space and you don't have the funding, the APAS provides quite a bit of benefit to expanding your capacity right now for doing more. Optimizing the clinical pathway, which we just talked about, and deliver this value-based healthcare where you can actually have space and time and resources to bring in more revenue-generating tests in your microbiology lab without adding more headcounts. So that concludes our quick rundown of the presentation. Now I'm going to step back and present, do the demonstration of the instrument. So I will switch cameras and head back there. Okay, so I hope everybody can see me. Right off the bat, the APAS Independence is it's a standalone automated system. It's actually on rollers, so you can roll it in any part of the lab. And it has a single 110 volt electricity requirement and a data connection. So that's it. So you can literally put it anywhere in the lab. And it's about 6 feet and 4 inches long and 30 inches deep. So same depth as your standard workbench. It's much easier to fit this anywhere, and it doesn't need to be pinned down to the ground or drilled into the ground. So it makes life a little bit easier. And it comes in one piece. So it's, implementation is literally one day. We can implement this, install it, and train possibly in the same day, in one day, which relieves a lot of pressure from the resources and the time you need when you think about total lab automation or many automation systems. This is very painless to put in and get it configured within a day. As I mentioned, this portion is where your quad racks go. This is where all the specimens go. And these racks were designed to be incubated. Now, right off the bat, whether you have a front-end processor or not, you can actually put all the plates right in these racks and put them in the incubator. In the morning, at any time that's suitable, a lab technologist or lab assistant, you don't need to have a CLS doing this, can bring the samples over, and they load them as many as 240 at a time. And all they do after that is they pick the application for, let's say, urines for this case, and they say run urines, they pick that, and the system is automated from that point. And so that's all the hands-on. So the next thing that happens, each plate gets barcode read and gets imaged. In this imaging section, all the lighting system is calibrated so the images are very clear from the bottom and the top. And that image is stored, interpreted, and based on your SOP, if it's completely negative, no growth, it gets sorted back into these quad racks. And the reason for that is there are a lot more negatives than positives. So these quad racks provide more space and capacity so we can put negatives in there. But also, if you reread, and I've learned a lot of facilities reread 48 hours or 4 hours for some of the young cultures, all you do is you take this and put it back. So you're a technologist, a microbiologist, not spending a lot of time moving, re-racking, racking plates. This really streamlines that. And all of your positives gets sorted. I think I moved this over into these single racks. And these single racks can be accessed at any point. So as these are being stacked, your microbiologist can take them up and work them up. So right away, you have access to all the single stacks as they're being processed. And in terms of, I think what's really important when you talk about automation is, well, maintenance. What does this need? There isn't anything here that you need to change or replace or do what weekly, there's no daily maintenance, but weekly, we're just wipe down the surfaces because it's so sensitive that we want to make sure there's no dust. So we just wipe down surfaces once a week, and once a year we have a PM where an engineer comes and just goes through the whole thing for 4 hours and gets it up to date. You're good to go again. So that's as far as the maintenance. So imagine a 10-minute maintenance a week, 5 minutes a day just to wipe things out if it's too dusty in your lab, and that is all the maintenance you need to do with the APAS independence. And it really fits within anyone's workflow, whether you have full automation system or front-end automation system or no automation system. This is complementary to automation systems too. If you want to have an FDA cleared system that can read and interpret results and can figure out whether you have growth, no growth, non-significant growth, or if you have mixed culture, this is a system that can actually interpret in that fashion. And that's all I have for today. I hope this was informative, and I will switch cameras and take any questions that you may have. Oh, very good question. So are there media brand restrictions? AI has to be done for every plate, for every manufacturer, because the reflections, the colors, and everything changes for the background. So we have to actually design a module for every single different media type. So very good question. Currently, we have Remmel by Thermo Fisher. So those plates for McConkey and blood. We have BD that we have already worked on. So BD plates for, again, McConkey and blood. And for MRSA, we have both BD and Remmel by Thermo Fisher. So those are the ones that we have developed so far, and we are pretty much not going to do any other ones because those are the biggest ones, and they take a lot of time and to even try to go outside of that. So those are our two top ones. Another good question was the size in terms of requirements. So I mentioned that the dimensions, but how much clearance does it need? It needs about a foot of clearance on either side. So on 4 sides, you just need to have clearance because there's ventilations and there's fans to suck air in and out. So you would need about a foot around it. Another very good question is that if a lab makes their own media, can this be configured and calibrated? The answer is no. Now, it's sort of yes, but it won't be FDA cleared. So if you have your own media, we have to literally develop and train the algorithm for that media. So it's not very practical. Okay, another good question. Can MEC and blood auger plates remain together in racks, or do they need to be in separate racks? Currently, the way it is set up, you have to have them in separate columns. So you would have your McConkey in one column, and you would have your blood in the other column. It reads it that way. By the end of this year, we're adding another feature where you could have it together. But as it is currently, you would have them separated. So that would be a change in the workflow where initially when you're processing your plates, you would just stack them separately and into those racks and incubate those in the racks, then you don't have to play with them at all anymore. And any plans to make alternate sizes of instruments, smaller, larger? Not right now. Not at the current, because the way we look at it is urine's the biggest volume, and that's where the ROI really is. And this system can handle some of the really large urine volumes that come into your laboratory. So this was kind of like the best start with the size. Can APAS incubate plates? No, this doesn't have an incubator, but it's also agnostic to any other incubators. Just like any incubator you have, it doesn't matter what it is, versus like a TLA where whatever you put on the incubator there, it gets processed. And if you incubate anything outside, it won't get processed. With the APAS, whatever incubator you use is fine. Are we working on chromogenic agar for yeast? Not right now. Do we have algorithms that can perform the ID of colonies based on the media if you're using chrome auger? That for urines that is. That I need to check. I'm not sure if we're working on that or not. That's a good question. And it says, can the system read a Keystra plate? To be 100% honest, I'm not sure what a Keystra plate is or how big it is. I can tell you what it can read. Anything that I mentioned in those set of criteria, urines, MRSA, VRE, CRE, those things, as long as the plates are 90 millimeter plates, we can only process 90 millimeter plates. Can the system only read a loop streak plate? So we can, any of these processors, Keystra, WASP, or manual streaks, any streak pattern doesn't matter. We can read any of them. And it's configured for 10 microliter loops. So as long as you're doing 10 microliter loops, then we can read any of them. 1 microliter loops we can do. So it doesn't matter, yeah, what streak pattern you use. I hope I answered that question. This was an amazing session with 14 questions already. That's phenomenal. Thanks, you guys. Let's see, here we go, one more. Okay, can you have customized programs for other culture types as long as you validate it? Yes, we can certainly do that. We have the expertise to do that as long as you want to partner with us, and we can definitely validate it. Any of these that are non-FDA can be validated in-house, and you'll be able to run it, no problem. If there are no other questions, I want to thank you for your participation, being with us, and those that have been with me a few times before. It is great to see you again. Have a wonderful day. and I will follow up with you soon. Cheers.